How's it going, guys? Vlad here, and welcome to the mesh analysis tutorial. Since you guys been requesting that a lot on the nodal analysis video, I decided that I would show you how to perform the mesh analysis. So let's get right into it. So first circuit that I got for you here already has the three meshes identified by I1, I2, and I3. So what I want to point out is that when you perform mesh analysis, you want to think in terms of voltages. So versus nodal analysis where you think in terms of currents. So let's get started. So I1, you go in a mesh circle. So first of all, you have the resistance of 2 ohms here. So what is the voltage equal? So this is I1. So here, what is the voltage equal to? V equals IR. So obviously the voltage is 2 times I1. Okay, so you keep on going through the loop, so you get to the second resistor. So here you have 9 ohms, so you can write 9. And in this case, what I want you to notice is that since you're going with I1, your I1 is going to be positive, so I1. And because I2, when you go through this circle, it goes in the opposite direction, you can write minus I2. Okay? We keep on going, so here you enter from the negative side of the battery, so you're going to write minus 18, and all of this is equal to 0. So that is the first equation that we have for I1. For I2, we do it in a similar fashion, so let's start with the battery. So in this case it's going to be plus 18. We're going through the 9 ohm resistor, so plus 9. And in this case, since you're doing it in terms of I2, you're going to write I2 minus I1. So once again, I1 is going in the, as you can see, in the clockwise direction. So this is how you travel through I2. And I1 is going the opposite way through this resistance. So since you're doing your equation in terms of I2, you're going to do I2 minus I1, followed by the 7 ohm resistor, so plus 7, and here you only have I2, so I2, and finally the 6 ohm resistor, so plus 6, and here you have, in a similar fashion, I2 minus I3, right? And all of this is equal to 0. What else do we have? So I3, for I3 we have, let's start with this resistor, so 6 I3 minus I2 plus the 3 volt battery. As you can see, we enter it from the positive side, so it's plus 3 plus 3 and your current I3, right? So we are left with 1, 2, and 3 equations. So let's write them all out. So 2I1 plus, and I'm going to open the parentheses at the same time, 9I1 minus 9I2 minus 18 is equal to 0. The second equation is 18 plus 9I2 minus 9I1 plus 7I2 plus 6I2 minus 6I3 is equal to 0, and the last equation, 6I3 minus 6I2 plus 3 plus 3I3 is equal to 0. So these are the 3 equations that we are left with for this particular circuit, and I'm assuming that you guys are able to simplify. So here you have 11 I1s. Basically it's 3 equations, 3 unknowns, so you should be able to use the matrices, or you should just replace and go back and solve for I1, I2, and I3. So once you have I1 and I2 and I3, what can you do? Well, you have a voltage here, right? So if you have the current I1, you should be able to find the voltage across this resistor. So let's call this V1. So V across this resistor would be I1 times R. Similarly, you can do this for any other resistor, and pay attention that the voltage here would be an equation of I1 and I2, so you can't just simply ignore one or the other. So that's it for this circuit. Let's take a look at the second one. Alright, so in the second example, we're asked to find Ix and Iy. We are not given any of the mesh loops, so let's specify them as such. This is going to be I1, we're going to have I2 and I3. So there's nothing exceptionally complicated in how you specify them, unless you get current sources, which I'm gonna get into a bit later, but so far we haven't stumbled onto any, so let's just keep it pretty simple. So for I1, similarly how we did in the previous example, we're gonna go in a loop. So here you have a 4 ohm resistance, which is multiplied by I1, plus the 6 ohm, which is multiplied by I1 minus I3. We also have a plus 6 volt, and all of that is equal to 0. For I2, we got one resistance on its own, so 12 times I3 plus 3 ohms, I3 minus I2, and once again this is minus because the direction of I3 in this particular branch is this way, and the direction of I2 is this way, so that's why in terms of I3 this is the positive direction, and in terms of I2 that's the negative. Plus the 6 ohm, and here we have I3 minus I1. All of this is equal to 0. Sorry, this was actually I3, and I2 we have 9 ohm times I2 minus 6 volts plus 3 times I2 minus I3 equal to 0. Right, so we are left with basically 4 equations, so let's rewrite them. For I1 plus 6I1 minus 6I3 plus 6 is equal to 0. 12I3 plus 3I3 minus 3I2 plus 6I3 minus 6I1 is equal to 0. 9I2 minus 6 plus 3I2 minus 3I3 is equal to 0. So once again you have 3 equations, 3 unknowns. You guys should be able to solve that pretty quickly. A quick tip that I want to give you actually is, as you do more and more of these, as you can notice, there's 6I3, 3I3 and 12I3, right? So this comes from this 12, 3 and 6. You should be able to just recognize them from when you do the mesh analysis, and you should be able to just in your head write it out as 12 plus 6 plus 3, so 12 plus 9, so 21I3. So for example, for doing the full mesh, you should be able to see the sum right away, so 21I3, and here you see minus 3I2 minus 6I1 is equal to 0. So as you practice more and more, you're not going to have to simplify these equations, open the brackets. You will be able to just write them out in one go. So if you have any questions about mesh analysis, please let me know in the comments below. I'm planning to do some more tutorials on dependent sources, on current sources, so super meshes, super nodes. So let me know if there's anything in particular that you would like to see. Thank you guys for watching. Bye.